Okay? Lecture number 34. First, before I go into announcements, I just wanted to say thanks to everybody who filled out the survey. It unfortunately wasn't 85% of the class and no bonus points, but you may have helped future generations of students. Was that a question? No, I tried to come up with a percentage that the class would barely reach, but I was wrong. Too bad for you. 78% of people filled it out. So, maybe next time. Now, does anyone care about this kind of thing? Well, it turns out that I asked students last semester, how much SQL do you want to learn? Do you wish you had learned less or more? The most popular vote was one more lecture than we learned. So this semester you get one more lecture on SQL than the students last semester. If you don't like it, blame them. This is brand new material, first time ever in 61A. But first, announcements. Project 4 is due on Thursday. If you want a bonus point, you can get that regardless of what other people in the class do, just by turning everything in today. There's also a recursive art contest. Entries are due by Monday. You just email your code and a screenshot of your art to Albert, CS61A-TAE. This email address is at the top of cs61a.org if you forget what it is. I'm so excited to see what you come up with. Homework 9 was merged into Homework 10. Both will be posted soon and will be due next Wednesday. And there's also a quiz next week just to make sure that you understand what's going on in SQL before the final exam rolls around. There will be a quiz released on Tuesday and due on Thursday. There are 5 more lectures in this course. On Friday, there will be a guest lecture from Soumya Basu, who's one of the TAs, because I'm off campus. And then there are 3 lectures from me next week, and then we're finally done. Okay. So we're going to keep talking about SQL. There's one example from last lecture that I didn't get to that I kind of like, so I'll go through it now. There was a famous meeting between 2 mathematicians when G.H. Hardy went to visit the mathematician Srinivasa Ramanujan, and he took a taxi to get there. And his first remark was, "I rode in taxi number 1729. What a boring number." Srinivasa responded, "No, it is a very interesting number. It is the smallest number that is a sum of 2 perfect cubes in 2 different ways." That's the story. Okay, so how would we find the smallest number that's the sum of 2 perfect cubes in 2 different ways? Well, we could use SQL. So last time, we created a table of pairs of numbers. Let's walk through it again together. We create the table called pairs by creating a local table called I with a column name n. N can be 1, or n is n plus 1 for any other row value n in the table. As long as n was less than 50, then we add n plus 1 to the table as well. So this was a recursive definition that gave us a table of all the numbers 1, 2, 3, 4, 5, 6 up to 50. And then we selected from that pairs of numbers. So a.n and b.n as column names x and y from a join between the table I and itself, where we restrict it to be that a.n is less than or equal to b.n. So we have 24 and 36, but not the opposite, 36 and 24. Questions about that? questions about that? Okay. So now we have all pairs of numbers. I could load this and then select X and Y from pairs, and I'll get a bunch of different pairs. Now, if I want to figure out when I have two pairs that if I represent the sum of two perfect cubes in two different ways, a natural way to do that is first to define a separate local table called cubes, where cubes has x and y, and then the sum of x cubed plus y cubed. Now, it's not necessary that we define this separate table, but it's going to make the eventual expression simpler. So for every x and y from pairs, we're just going to actually compute x cubed plus y cubed. Now, once we have cubes defined in this way, we can select pairs of rows from cubes that have the same cube sum. So what we're going to select is everything. A dot x, A dot y, B dot x, B dot y, A dot cube. And what are A and B? Well, those are both two different cubes tables. So we join cubes as A with cubes as B. I'd like to give a new name to the A dot cube column, so I'll call it the sum cubes column. And then what constraint do we have to impose? Well, we want it to be that both of the sums of the cubes are the same, but they're in different ways, so that we can put all that in a where clause by saying where it's the case that A dot x is not B dot x, and we'll order them just so that we only get one order instead of both. And it's the case that sum of the cubes of x and y in A equals the sum of the cubes of x and y in B. Now we want the smallest such number, so let's order by sum cubes. Okay, so now when I run this, I create the table pairs, and then it executes this select statement, which tells me that if I take x and y as 1 and 12, cube them both, I get 1,729, which is the same number that I get by cubing 9 and adding that to the cube of 10. Oh, what an interesting number. Now, there are several other numbers that are the sums of two perfect cubes in two different ways, such as 4,104 and 13,832, and all the way up to 110,808. So these might all be qualified as interesting numbers, but only the first one is a very interesting number because it's the smallest. Any questions? There's a lot of stuff. I know we talked all about this last lecture, and now it's this lecture, so if there's something that's confusing you, it's probably confusing another 30 people in the room. You could feel free and ask it. Okay. What happened? Oh, wrong presentation. Okay, so the last thing we're going to talk about with the SQL language is called aggregation. So far, we've been mostly manipulating individual rows and collecting them into a new table. But what aggregation does is it computes something across multiple rows. So far, we've written a lot of select statements, SQL expressions, right? So a select statement includes SQL expressions. And they always tend to refer to the values in a single row. So what do I mean by that? Well, you start with some table, which may be created through a join, and then you filter the rows of that table using a where expression. And that where expression, which says something like the latitude has to be bigger than 38, gets computed for each row individually, and then you keep some of those rows and you get rid of other rows. And similarly, the order by expression gets computed for each row, and then we sort all the rows based on that. And within the column description, there are expressions that tell you how to come up with a value for a particular row based on a row that was in table in the first place. So everything refers, all these expressions can include column names, but when you include a column name, like latitude, it's referring to the value of latitude in that row. An aggregate function is different. It can appear in any of the expressions in the columns clause, and it computes a value from a group of rows. Okay, we're going to start with a new example, an example of a table of animals. I was thinking of some animals, and I thought of a dog, which has 4 legs and a weight of 20 pounds. A cat has 4 legs and a weight of about 10 pounds. A ferret has 4 legs and a weight of about 10 pounds. Parrot rhymes with ferret. It has 2 legs and a weight of about 6 pounds. A penguin is a larger bird which has 2 legs, weighs about 10 pounds. And then I asked my wife, what's something with 2 legs that weighs a lot? And she said a T-Rex weighs 6 tons. Okay, so there's my table. Here is the first ever select statement that includes an expression with an aggregate function. Max is the aggregate function. This computes a table with a single row. That row contains the value that you get by maxing over all the values of all the legs anywhere in the table. So when I say aggregate function, I mean something like max. It can appear here in the column description, and it has this funny effect that it collapses a bunch of rows together into just one row. And that row has a value that is computed from the values in all the different rows. Oh, we'll get there very soon. Good question. Okay, let's play around with this a little bit, and then we'll look at extensions. So, goodbye, interesting number. Hello, animals. Select the maximum legs from animals, gives me 4. Select the sum of the weights of all the animals. Oh, don't mess with me. Sum of the weight of all the animals. So here we name the column weight, and it sums together 20, 30, 40, 50, 56, 12,056. Now, you can sum or max any expression that you want. I could select what I get when I compute the max of legs minus weight plus 5 from animals. Okay, so that'll find all the rows where it computes the legs minus the weight. How do I get a large number for that? Well, here's a parrot which has legs 2 minus weight 6 is -4, and then I added 5 to it, and I got 1. What if I select the max of the legs and the min of the weight from animals? Well, these two things are computed independently. So there's no 4-legged animal that weighs 6 pounds. So instead, I got the max of the legs by looking at everything in the legs column and finding a 4, the min of the weight, which is here at 6, but they come from different rows. And we can combine these expressions however we want. Instead of putting them in separate columns, I could just subtract the min weight from the max legs. And it's actually going to aggregate all of the different values of legs, aggregate all the different values of weight, find the max of one, the min of the other, even if they come from different rows, and then it will subtract them. Question? Can I get the number 2015? Yeah. Oh, I feel really bad about that. Okay. How are we doing? Oh, more examples. So someone, you asked a question, what happens when you have an aggregate function and you just have a regular expression that comes up with a value for a particular row? You can mix these two things together. Sometimes you get something useful, and sometimes you don't. An aggregate function selects a row in the table in addition to computing a value. And so other expressions use that row in the table, and so you may get something meaningful. What do I mean by may? Well, it depends on how you're aggregating. So if I say select max weight, comma, kind, it's going to aggregate all the weights to find the maximum. That would be the T-Rex. In addition to finding this value, 12,000, it will select a row, and it evaluates kind just for that row. And in this case, it will say T-Rex is the kind of thing that gives you this maximal weight. So you'll get a one-row result where the max weight is 12,000 and the kind is T-Rex. Select max weight, comma, kind from animals. And it'll tell us 12,000 is the maximal weight, and the T-Rex gave it to us. Now this is basically useful for max and min. So if you say, what's the min kind, comma, kind from animals, it will look at all the kinds, compare them alphabetically, find that the minimum kind is cat, select that row, and then we'll have cat, comma, cat. So what happens when you aggregate in multiple different ways? We just saw that actually those aggregations can select out values from different rows. That's no problem. Now you might wonder, what row does it pick to compute everything else? And here's where this system of mixing together aggregations and non-aggregations becomes very unreliable. So if I select, I want the minimum weight and the max legs from animals, it's going to find, oh, the min weight is 6, the maximum legs is 4. But then if I say, what kind of animal is that, it will give me an answer, but that answer is effectively meaningless. It says cat. Okay, so what is cat? Is it the maximum legs thing or the minimum weight thing? You can't tell. Turns out it's the maximum legs thing. But aren't there multiple maximum legs things? Well, sure. There's cat and there's ferret and there's dog, but it just picks one kind of arbitrarily. So you have to be very careful if you're going to mix together aggregation and non-aggregation that there's only one sensible answer. Because if there's multiple sensible answers, it will just give you one arbitrarily, and you don't really have much control over what it's going to do. Yeah, I guess we don't know. Okay, so what are some other examples of things that don't make sense? Well, if you select max legs, comma, kind, what do you get? We saw, oh, we didn't really try it. Oops. Select max legs, comma, kind from animals. We get the cat, which is not wrong, but it's not right either. And what if you select the average weight, comma, kind from animals? Well, you can compute averages. Select the average weight from animals, and it will sum them all up, divide by 6, and tell you that the average rate is about 2,000, which is the sum 12,056 divided by 6. And you ask, what sort of beast weighs 2,000 pounds? Well, it tells you T-Rex, but that is a completely useless value in relation to average weight. So you're basically just selecting some value at random. Okay, so be wary. You may want something like, what's the thing that gives you the maximal weight? You can get it like this, but this kind of expression starts to break down whenever you do anything even remotely complicated. So the question is, how would you find all of the different animal kinds that have some maximal weight or maximal legs? So you want to select the kind from animals. Now, if I just put max leg here, you run into trouble. It says misuse of aggregate function max. And that's because the aggregate functions are supposed to appear in the column descriptions, not in the where clause. Now, you could build a table that contains the value that is the maximal legs and then use that in a join. So that would be a natural thing to do. You could say with so many legs select the maximal legs from animals. Select every kind from animals where the legs equals. Oh, so now here we're going to have to join this with the so many legs table. And then we can say where legs equals n. And then we've got the cat, the dog, and the ferret all have 4 legs. So we built a local table with only 1 row. When you join all rows of this with a 1-row table, it's like you're able to access the value in this 1 row at the same time that you evaluate every row of here. And so you can get n, which is the column name for so many legs, and legs, which is the column name from the animals table, and check that they're equal. Question? So the question is, can you build a new column that's the sum of 2 existing columns, or some combination? Yeah, you can certainly do that. So for instance, if we had the pairs table, you could build a new column that was the sum of x and y, just by writing x plus y as the column description. Onward? If you don't want to go onward, the easiest way is to ask a question. Okay. Onward it is. Yeah. Yeah, so if we run max legs, select max legs from animals, we see it only has 1 thing in it. That's the whole point of max, is it aggregates over everything in animals and gives you 1 value. This is a name of a local table, and this is the name of the column within that table. So this would be the same as writing create table so many legs as select max legs as n from animals. That would create an equivalent global table. So now we can look, what's in so many legs? Select star from so many legs, and it's just one row with 4. Then I can just drop that. Cat, dog, ferret. You got it. Question? Like that? Well, then, yeah, I would join both of these rows. So you'd get all possible combinations of an animal row with one of these 2 rows, and you'd check whether legs equals 2, which it would be for these. And so when we run this thing, we'll get a list of a lot of animals. Did I save? Okay, get a list of all the animals. Okay, this is getting to be a pretty complex example, so let's scoot on to the next thing. Groups. So I said that an aggregate function computes a single value from all of the different values that you get from all of the different rows in a group. And so far, in every definition that we've seen, all of the rows have been in one big group. So when I max the legs of everything in the animals table, I group together all of the different rows in the animals table, I compute the max of the value for legs, and then I get only one row in the result, because there's only one group. But in fact, it's possible to have multiple groups and compute a result row for each group. So rows in a table can be grouped. An aggregation, meaning things like max, is performed on each group. This looks like what you saw before, but in fact it says different things on the screen. So let's read it together. Select columns from table, group by expression, having expression. Whoa, there's all kinds of new stuff here. Okay, so group by is brand new. It's going to allow us to form groups. Having is also brand new. Having I'll talk about later, but it's a way to filter groups instead of just filtering individual rows. So where gets rid of a row if it doesn't meet some expression. Having will get rid of a whole group. What do I mean by group? Well, what you do is you put an expression in group by, and it will form a group for each value that appears in that column. And so the number of different groups will be the number of unique values that appear for some expression. So here's the table that we had before. If I say select legs, comma, max weight from animals group by legs, what it does is evaluate legs for each row, and it finds that some of them have the value 4 legs, and some of them have the value 2 legs. And so the group by clause here means that there are 2 groups. When you aggregate, such as by saying max weight, it takes the maximal weight over the different rows in that group, but it doesn't mix groups together. And so you get the following table. 4-legged beasts have a maximal weight of 20. 2-legged beasts have a maximal weight of 12,000. The reason there are 2 rows in the result is that there are 2 groups. The reason there are 2 groups is that there are 2 different unique values for this expression, legs. If you group by weight, how many groups will there be? Good question. Talk to the person next to you. See if you can figure it out. If I group by weight, how many groups will there be? There will be the 20 weight, the 10 weight, the 6 weight, and the 12,000 weight. So there will be 4 different groups. And therefore, I'll have 4 different rows in the output. Let's do some demos. Select legs, max weight from animals, group by legs. So this is in a different order, but it's the same result that you saw before. 2-legged beasts, 12,000. And if you want the min weight, you can do that too. Okay. Yeah, you could group by legs and then express some ordering. So you could order by legs, and then you'd know what order. It came in. Yeah. Now, what if you want to know how many things there are that have a certain leg count? Well, there's an aggregate function called count. Now, if I say count legs from animals, it might not do what you expect. It says there are 6 legs. Well, what does that mean? It just means there are 6 different leg values. Basically, there are 6 different rows. This is such a common thing where you're counting how many different entries there are in a table that the more common way to express the same thing is by saying count star. Now, this star is something that's only used in conjunction with count, not with max or min, and it says how many rows are there. So how many rows are there in the animals table? There are 6. If I want to group things by legs first, then I'll see that for 2 legs, there are 3 different rows, and for 4 legs, there are 3 different rows, which is what I'd expect. Cat, dog, and ferret versus parrot, penguin, and T-Rex. So count is pretty flexible. You can count the number of rows. It's kind of weird to count the number of legs because you end up including repeats. But if you wanted to exclude repeats, you can also say count the distinct number of values for the expression legs. And then it will only count the unique ones. So you could have 4 legs or you can have 2 legs, so there's 2 different values for count distinct legs. And there are 4 different values for count distinct weight. Which is the same number of groups that you get when you group by weight. Okay. Gets a little bit crazier. You can group by anything you want. Check this out. Select weight divided by legs, how much weight you have to support with each leg, and the count of how many different beasts have that weight-to-leg ratio. From animals. And in this case, I'm going to group by this ratio. What's your weight divided by your legs? Now, when you divide in this way, SQL performs integer division. So when you divide 10 by 4, instead of getting 2.5, you get 2. So that's why there's a 2 here instead of a 2.5. But what this says is, for the value 2, or 2 pounds per leg, there's 2 such beasts. They're the cat and the ferret. For 3 pounds per leg, well, that would be the parrot. And what about 5 pounds per leg? Well, there's 2 of those. That would be the penguin at 10 pounds for 2 legs, and the dog, which has 20 pounds for 4 legs. And then there's the T-Rex, which has a humorous amount of pounds per leg. So here I've grouped by an expression that combines multiple different values within the same row. Counts are just counts how many rows are in the group. If you group by something else, you can still compute this expression if I put everything in the same group or whatever. I have no idea what that did. Okay, so you're wondering what happens if you group by something and you put something else here. You can do it and you don't get an error, but it's often that you get nonsense as a result. So be consistent when you write down what you want. Yeah, you can count star, means count all the rows. You can count some particular expression like legs, and then it'll count all the rows again. So it'll count any row that has a legs value. But since you get the same result both ways. So the reason they're different is actually that you can have missing values in SQL, which is something we won't talk about in this class. And so this draws a distinction between the two. But pretend I didn't say that. Okay, now what if you only want some groups? Rows in a table can be grouped. Aggregation is performed per group unless the having clause tells you you don't care about that group. Select weight divided by legs and the count of how many rows have that property from animals where I group by weight divided by legs, but I only want groups having count greater than 1. So what happens here? Well, group by expression tells us how to group things together. So it means we have to evaluate what's the weight divided by legs for each row. 5, 2, 2, 3, 5, and 6,000. Now I've color-coded this because it groups together these two rows which have value 2, these two rows which have value 5, and then there's two more groups that have only one thing in them. But the having clause says I only care about the groups that have more than one thing. And so I end up only with the values of weight per leg that happen at least twice. So what is the difference between having and where? Where filters individual rows. You cannot include aggregation in a where clause. Having filters out whole groups. And you can do things like ask what's the count of the number of things in the group, or what's the maximum value in the group, and filter by that. So it's whether or not you can put aggregate functions inside the expression. So those two went in there, those two went in there. Okay. Talk to the person next to you. See if you can figure out how to write a statement that would give you the maximum difference between leg count. So a horse versus a spider has a leg difference of 4, because 8 minus 4 is 4. Maximum difference in leg count for two different animals that have the same weight. Talk to the person next to you, see if you can figure it out. Go. Okay, I wrote this slide at 2:09, 1 minute before lecture started, so I don't know whether I can get it right or not, but we just discussed it, and so hopefully we will. So how do you get the maximum difference in leg count between two animals? Well, in order to do that, you have to be able to talk about two animals at the same time. Oops. So how might you do that? Well, you have to select from animals joined with animals. And since it's the same column twice, you have to say animals as A, animals as B. Okay, so now we're talking about ferret and cat at the same time, and therefore, we can add a where clause that makes sure that they have the same weight. A dot weight equals B dot weight. So now we're down to pairs of animals that have the same weight. And we'll see sometimes you get the same animal twice, cat and cat. Sometimes you get cat and ferret. Sometimes you get cat and penguin. And that's particularly interesting because there's a different number of legs here. So instead of selecting star, I could select the maximal difference between the legs of A and the legs of B. From animals as A, animals as B, where they have the same weight. And the answer is 2. Okay, because the biggest difference you can find is that the penguin and the cat have the same weight, but one has 4 legs and one has 2. Did anyone else come up with a different solution? Oh, question in the back first. Yeah, so this does have weird stuff in it, like it says the difference between the penguin's legs and the cat's legs is -2, so we might want to put an absolute value in there somewhere to fix that. This has things in it like, what's the difference between the cat's legs and the cat's legs? Well, that's 0, because they're both a cat. But still, within that maximum, it is going to consider the case we want, which is comparing the cat and the penguin. So here's an example where we're using lots of different ideas together. We're using joins in order to talk about 2 rows. Whenever you say 2 different things have the same property, you often have to join those together and then use a where clause to figure out where they're the same. And then that built us a big table, and we applied aggregation in order to pick out the maximal value. Yeah, but if we put that in, we get the same answer. So the question is, what if I also said, and A dot name is less than B dot name? Oh, sorry, it's called kind. Yeah, so I guess the most precise way to write this might be take the max of the absolute value of the difference. And then we still want to say from animals as A, animals as B, and we want to make sure that they have the same weight, but they're not the same beast. That's a good answer, too. Question? So how do we see what are these maximal beasts? Well, then we need to list A dot kind and B dot kind. What'd I do? Oh, I forgot the from. And then I'll say, oh, it's the cat and the penguin. Okay, I'm going to show you something. Something that probably has never been displayed in an Intro CS course. Ever. Which is the entire grammar for the select statement. What's a grammar? A grammar is a description of all possible different select statements. So the grammar of English tells you all possible sentences and their structure. The grammar of a select statement tells you what are all the different possible combinations that are allowed. And there's lots of different ways to write down a grammar, but one of them is to draw boxes and arrows. And in this diagram of the grammar, it says you have two options. You can include a with clause or not. Now, after the word with, you can include the recursive keyword, which in fact does nothing at all, because you can be recursive with or without this. And then you include a common table expression, so those are the tables within the with clause. Whether you include that or not, you have to say select. And then we didn't talk about that, but you write down the result columns that you want. And then you say from, and then you say where, and then you say group by. So in this course, oh, and then it keeps going. Sorry. So group by, and then see that circle right there? That's the same as that half a circle right there. I just couldn't fit it all on one slide because it's huge. So this line is the same as this line. You'll just have to use your imagination. This says after group by, you can actually have a compound operator, and then you can go back way up here and say select again. And then you can say order by, and then you can say limit, and then you're finally done. Now, we talked about with. We talked about select. I skipped distinct and all, but you can look them up. They're kind of boring. Result column is the column description. You know what that is. You know what a from clause is. In all of our from clauses, we've just written down tables. In fact, you can write down whole select statements there, but we won't do that in this class. We talked about where, we talked about group by, we talked about having. Values is really boring. It just means you can list out all the different values in a comma-separated list. So I skipped that because it's boring. What's this compound operator? Well, that's union. So if you write select blah, 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 union, select blah, 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 then you get a select statement over a whole bunch of stuff. There's also intersect and a set difference. And we talked about order by. Oops. And we talked about, oh my goodness. And we didn't talk about limit, but I think it showed up in your lab. And it just limits the number of results. So I focused on all the interesting parts. Anything I left out was just not that interesting. And now you know everything that can possibly go in a select statement in the SQL language. Nice. Okay. See you. So I'll see you on Monday. But there is lecture on Friday. It's a guest lecture. Bye.